In this lesson, we're going to solve several problems that can be solved by setting up and solving proportions. And our first problem involves a toy company that wants to make an action figure of a superhero, and the superhero is 75 inches tall. The toy company wants the ratio of the action figure to the superhero to be 3:5. How tall should the action figure be? So this is the proportion we're going to set up. H will stand for the height of the action figure, and that is to 75, the height of the superhero, as 3 is to 5, where 3:5 is the desired ratio. So we apply the means extremes property, and we get that 5h is equal to 75 times 3. And then we know that h is equal to 75 times 3 divided by 5. Well, 5 goes into 75 15 times. We cancel, and then we simply do 15 times 3 to get 45 inches, the height of a pretty tall action figure, 45 inches. In this problem, we're looking at the Washington Monument in Washington, D.C., and on a sunny day, it casts a shadow that is 142 feet 5 inches long. And at the same time, a 156 centimeter tall person standing near the monument casts a shadow that is 40 centimeters long. Our job, find how tall the Washington Monument is. We can set a proportion here because when things are nearby one another, the angle of the sun is the same, so the shadows of things are proportional to their heights. And often people know their height, in this case, the person who's 156 centimeters tall, and shadows are fairly easy to measure because they're on the ground. That allows us to get measurements of things like the Washington Monument, or trees, or flagpoles, or things that would be quite difficult to climb up and measure with a traditional measuring tape. But the first thing we need to do is deal with the 142 feet 5 inches. A common error is to write 142.5 feet, but there's 12 inches in a foot. So 142 feet 5 inches is 142 and 5/12 feet. And I personally would rather not work with a fraction like 5/12, so I'm going to remedy that by converting it into inches. And to do that, I start by writing 142 feet 5 inches, and then I know that there's 12 inches in a foot, so I multiply the 142 feet by 12, and that gives me 1,704 inches and 142 feet. I add the additional 5 inches, and I get that the Washington Monument is 1,709 inches tall. And now I can set up my proportion. The height of the man, 156 centimeters, is to the length of his shadow, 40 centimeters, as the unknown height of the Washington Monument is to 1,709 inches. Now, in each ratio, the units are different, but the units are the same in each ratio. For the man, he's measured in centimeters, so the ratio is centimeters to centimeters. And for the Washington Monument, we're using inches, so it's inches to inches. So this is still a proportion because each one is a ratio, and a proportion is a statement that two ratios are equal. So we apply the means extremes property to get that 40h is equal to 156 times 1,709. We then know that h is equal to 156 times 1,709 divided by 40. We'll let a calculator do this one, and we get that h is 6,665.1 inches. Now let's convert it back to feet. Divide it by 12. We'll let the calculator do that too, and we get that h is 555.425 feet. So I think we can round and say that the Washington Monument is about 555 feet tall. And if you go to the National Park Service website, 555 feet is the number given for the height of the Washington Monument. Polygons that have corresponding angles with equal measures have corresponding sides that are proportional. They are called similar polygons. Below are two similar trapezoids, and we're going to find the lengths of the sides that are now labeled with variables. Well, the first thing we're going to do is recopy our polygons and then leave us some room to work underneath, because I think we all remember what the problem is. And then we're going to look and find two corresponding sides where we know both lengths. And it's the two that I just circled. The bottom side on the blue, 8 centimeters, and the bottom side on the orange, 12 centimeters. So there's our ratio that we're going to use for all of our proportions, 8 to 12. Now we're going to pick one of the variables, and let's pick variable A. And we see that A is the unknown length of the left side of the blue trapezoid, and on the orange trapezoid, the left side is 6 centimeters. So our ratio is A to 6. We cross multiply, and then we know that A is 6 times 8 over 12. Well, I know that 6 times 8 is 48. 48 divided by 12 is 4. So A is 4 centimeters long. Well, I'll write that up at the top. And now we'll look at one of the other variables. How about C? I don't know where the letter B went, but we'll go to C because there is no letter B. We see that C is the length of the top side on the blue trapezoid, and 7.5 is the length of the top side on the orange trapezoid. So our other ratio is C over 7.5. So what we're saying is that the length of the bottom side on the blue trapezoid is to the length of the bottom side on the orange trapezoid, as the length of the top side of the blue trapezoid is to the length of the top side of the orange trapezoid. Apply the means extremes property again. Divide by 12 to solve for C. And I happen to know that 8 times 7.5 is 60, and 60 divided by 12 is 5. So C is 5 centimeters. And we'll put that up at the top, and we have one left, and that's D. And in this proportion, the D is going to be on the bottom because it represents a length of the larger trapezoid, and so it has to match where the 12 is, which is on the bottom of the first ratio. So the 8 is to 12 as 3 is to D. We cross multiply. We divide by 8, and we know that 12 times 3 is 36. And if you can't do it in your head, get out a calculator. But 36 divided by 8 is 4.5 or 4.5 centimeters. So the three answers, A is 4 centimeters, C is 5 centimeters, and D is 4.5 centimeters. Problems that involve percent can often be solved with proportions. So here we have a school with 260 total students, and 65% of those students are above average. We need to find how many students are above average at this school. Well, we know that 65% is 6,500, so we write 65 is to 100 as the number of above average students, which we'll call A, is to 260. We apply the means extremes property, divide by 100, we get out our calculators, we do 65 times 260, get a product, and then divide that product by 100, and we get that A is 169 students, the number of above average students at this school. And for our final problem, we go to the game of basketball, a very commonly sought statistics, shooting percentage. A team made 20 of 42 shots. What was the shooting percentage? Well, we'll call the shooting percentage S, and we know that S is to 100 as the 20 made shots is to the 42 shots taken. We apply the means extremes property, divide by 42 to solve for S, get out our calculator, 100 times 20, then we divide by 42, doesn't come out even. Shooting percentages rarely come out even. We often round, often to the nearest tenth, so we'll say that this team shot 47.6% for the game, and we've used a proportion to solve this problem.